upon concepts we cover, I'm going to focus on the most difficult concepts in the unit. In this unit, we will probably have two, one for square numbers and the other one on Pythagoras' theorem. I thought I would start with square numbers today. Basics of square numbers. Square numbers are any number multiplied by itself will produce a square number. So, for instance, 1 times 1 gives us 1. It means 1 is a square number. 2 times 2 gives us 4. 4 is also a square number. 3 times 3 gives us 9. It means 9 is a square number, and so on. This is a quick way to make yourself a list of all the possible square numbers. Now, that alone, this is the mathematical explanation of what a square number is. This isn't the actual meaning behind what a square number is, and that's what I'll show you next. Okay? So using this method, you should be able to find any square number, period, using this list. The actual meaning behind that I'll explain now. Alright, let's talk about the meaning behind square numbers. The word square number comes from the fact that square numbers are the only numbers that you can form a square out of, okay? And that may sound strange, but if we look at a pad like this, where we have unit squares, it'll make sense, okay? We're going to use the analogy of area. So in this case, we're going to talk about two numbers and how they look in terms of their area. Now, just remember that area is defined as the number of unit squares that make up the surface of an object. So in a nutshell, if you can fit 10 squares on an object, then it has an area of 10. If you can fit 4 squares on an object, it has an area of 4. The size of the squares will vary. If you're using meters or centimeters, the size of the square is different. In math, we're not as concerned about that. We're looking just at the principle. Now I have a number grid here that has squares that are all supposed to be a centimeter in size, okay? And what we're going to do is we're going to try and draw two different numbers in terms of their areas, okay? So let's start with 4. Now, area is length times width for any rectangle, okay? I'm going to start with 4. So I'm going to grab 4 squares. Okay? So this square here happens to be an area of 4. You can see that there are 1, 2, 3, 4 squares. Okay? So that's an area of 4. In this case, we can represent it as a square. So 4 is a square number. Okay? And I'll just color that in. If you can represent the number as a square on a grid like this, it is a square number. If you can't, it's not a square number. I'll show you an example next. So this was with 4. So 4 is a yes. From what we talked about on the previous page, if you'd already made your list, you would know that 6 isn't on the list. So 6 isn't a square number, but let me show you why. Alright, so let's try and make the number 6. Okay, so I'm going to do my best to make a square. If I start with one of 4, that's 4 squares. So let me just start with that. That's already 4 squares, so I need to add on somewhere. No matter how you add this on, you're not going to be able to make a square. So I'm going to try taking these 4 and adding on these 2 squares on the edge here. That's not a square. It's an area of 6, but it's not a square. So you cannot make a square shape that is represented by an area of 6. I'll try another one here, and I'll actually color it in. So let's try these 4. That's 4 squares. And then I'll try these 2 in the corner. So that's 6 squares, but you can see it's kind of like a Tetris piece. Again, it's not a square. So I'll color these in. That's 6 squares, but it's not actually a square shape when you look at the entire area. So 6 is a no. That's the actual meaning behind the word square number. If you can form a square out of it visually, it's a square number. That concludes our tutorial on square numbers. I will be doing another one on Pythagoras' theorem. If you have requests for a tutorial, just come ask me.